Howdy, AP PreCal. It is Miss Kosh. I want to work through Mr. Passwater's notes from 310. This is his 310 part 1, and I haven't looked at them. So here, I may have done them last year, but here we go. The first one, this is something, we've already done this in my class this year, and kids struggle with this idea a lot. The question is, are these two things equivalent? Well, what I have been doing to explain that is to show okay, how do I want to do this? If I graph sine of x, it looks something like this. And how many places does it equal 1/2? Well, there's infinitely many places. On this one, however, if I graph the inverse of sine looks something just like this. So if I plug in 1/2 as my input value, I have exactly one output value. Okay, and so are the two equations equivalent? No. If I want to find all of the values where sine of x equals 1/2, it would be, if they say find all, it would be x equals pi over 6 plus 2 pi k, and where x equals 5 pi over 6 plus 2 pi k. But if they introduce the problem by saying find the inverse sine of this equals x, x would equal just that positive pi over 6. I have other videos where I have tried to explain this multiple times. Go look in my playlist. I think, yeah, I've done it multiple times. I try to do it well here, but anyway, go hear a different perspective in one of my different videos. Okay, on the unit circle, we know that those, okay, so they're saying pi over 6 and 5 pi over 6. Due to domain restrictions, this has pi over 6 only. Okay, so yes. As a result, when we are solving trigonometric functions, we must modify our solution to account for any domain restrictions or the lack of any domain. I think this may be the part that has been messing up my kids. They'll see something and expect it to only be the restriction, but it may not be. Let me see if I can get to show you what I'm talking about. Okay. Since trigonometric functions are periodic, we can have infinitely many solutions onto an equation if no domain restrictions are given. So this was that plus 2 pi k. Okay, so here we go. So I would write plus 2 pi k, and I would write where k is an element of the integers. We call it kes. Same idea. So here, so writing general statements. Tangent, we know with tangent, it's the slope. And so that slope is a positive 1 pi units apart. So we can just say pi k. It's also the period. If you think about sine's period, it's 2 pi. Cosine's period is 2 pi. Tangent's period is pi. If this is your first introduction to trig, my video is probably going to go a little too deep because I'm assuming that you know how to graph trig function. I'm assuming you're really good at the unit circle, all of those things. Okay, so let's see. So go watch other videos, do some practice, and then come back. Okay, find all solutions to the equation cosine. So here's what I see. When I want to find all of them, cosine, this is the pi over 4 family. Cosine is the x value. It's negative, so x would equal, this one is 3 pi over 4 plus 2 pi k, and this one would be 5 pi over 4 plus 2 pi k. Hopefully you're really good at the unit circle, and that was quick and easy. Hopefully you answered it even faster than me. Okay, the next one, sine of x equals -1. Sine is the y value. Y equals -1. So it says find all, so we have to answer the question they asked. This is 3 pi over 2 plus 2 pi k. Find all solutions. Okay, so this one, let's rationalize the denominator. When we do, we get root 3 over 3. My kids, I stand at the front of the room and use my arm, and I talk about this has a slope that's 0, this has a slope that's undefined, this has a slope of 1. Those are the easy ones. Obviously, -1 also. And then we compare. We know that from the unit circle, we have a slope of root 3 or root 3 over 3. And so we talk about which is a bigger value, root 3 or a third of root 3. Root 3 is bigger, that's this one. Root 3 over 3 is smaller, that's that one. This is the pi over 6 family. X equals pi over 6 plus pi k, because maybe I should have written kes every time. There you go. Okay, solving trigonometric equations. Okay, so here's the steps that he writes out. Fantastic. Okay, so sine of theta equals 3 root 2 over 6. I can rewrite that as root 2 over 2. That's the pi over 4 family. It says what are all values? So theta would equal, this is going to be here and here, pi over 4 plus 2 pi k. and 3 pi over 4 plus 2 pi k, where k is an element of the integers. Okay, set these equal. So we want to know where the coordinates, so this one they've given us an interval. Okay, so we're going to take this 3 plus 2 cosine x and set it equal to 2. I get that cosine of x, I'm subtracting 3, that's -1, dividing by 2, I get, I forgot my equal sign, equals -1/2. Cosine is the x value, that's here and here. We went over a little and up a lot. And so you get one time around the circle and you're done. That's what this right here tells you. And so it would be 2 pi over 3 and 4 pi over 3, and we're done. If they changed it to find all, then I'd have to add my 2 pi k. Okay. When we went to square trigonometric functions, okay, I talked about this in a recent video. So if I have sine of x and I want to raise it to the nth power, we write sine to the n of x. Yeah. The one exception, though, is that when I write this, sine to the -1 of x, this means inverse function. It does not mean sine of x to the -1. So this is one exception to that one, this notation. Maybe to avoid the confusion, we should just always write that this is arc sine x, because then you don't try and use that same property. But anyway, luckily I have not seen anywhere in PreCal where they expect this to then become the reciprocal. That would just be wrong. Does that make sense? Okay, so, but we will write, instead of sine x squared like this, sine x quantity squared, we'll write sine squared x. Okay, so what are the zeros? So let's take this. 3 minus 4 sine squared x equals 0. Subtract 3, divide by -4. Negative divided by negative is a positive 3/4. By the way, if it had stayed negative, we'd have no solution, because then when I take the square root, I would get something non-real, which good luck. Okay, so square root, plus minus. So I find that sine of x is equal to plus or minus root 3. The square root of 4 is 2. Well, root 3 over 2 means that's my y value. I'm here and here, but I'm also negative here and here. So these two are pi apart, and these two are pi apart. So the easiest way to answer this question, or the most concise, oh wait, they wanted me to tell you this. Okay. Well, if it said find all, I would say pi over 3 plus pi k, and then 2 pi over 3 plus pi k, but I did not look at the directions until halfway through the problem. So I want pi over 3, I want 2 pi over 3, I want 4 pi over 3, and that one, 5 pi over 3. So just make sure you answer the question that was asked. What are the values of theta on this interval? Okay, we're cosine. So here, this is one of the things I saw my kids mess up on this year. They wanted to just divide by cosine and then move on with their lives. Well, think about this. If I have x squared equals 4x, and I just divide and say, oh, x equals 4 and we're done, it does equal 4, but there's something else it could equal. I need to subtract, set it equal to 0, factor. I like to say, what should we do next? Starts with an F and ends in actor. Okay, I think I'm hilarious. And we get 0 and 4, so that has two answers. Same exact idea over here. So we have to say cosine squared plus cosine theta is equal to 0. Let's factor out a cosine. This is another great one for a u substitution, but I thought it was easy enough that I didn't need to do the u substitution. Not a me substitution, a u substitution. Oh, I'm on a roll today. Okay, so cosine of theta equals 0. Cosine is the x value. It equals 0 here and here. Cosine equals -1 here. So they wanted to find on that interval, so theta would equal pi over 2. It would equal pi. It would equal 3 pi over 2. Okay. Now, okay, so we want to live in that world and we want to find the intersection. So 2 sine squared x equals root 3 sine x. Can you see what's coming? I can. So practice, and then you will start to see what's coming. I can factor out a sine of x, and I'm left with 2 sine x minus root 3. Sine of x will equal 0. When does sine, we'll do that in a second. And then sine of x would equal add root 3 divided by 2, so root 3 over 2. Thinking unit circle, when does sine equal 0? Sine is the y value. It's 0 here and here. When does it equal root 3 over 2? It's there and there. It never equals root 3, but when does it equal root 3 over 2? And so I see, so in this interval, they're allowing us to include 0, but they're not allowing us to include 2 pi. So I see 0, I see pi over 3, I see 2 pi over 3, I see pi, and they said don't use 2 pi, and we're done. I think, is that the end of part 1? It looks like it is. Well, should we keep going? I'm on a roll. Let's just keep going. Here comes part 2. It's 2 pages. Okay. So, okay, similarly we can solve inequalities. You know AP PreCal loves all things inequalities. So, good news, bad news for us. So here's a graph, and they're saying which are the values for which f of x is less than 0. So this would be 0. So where is it less than that? Or equal, sorry. I see from negative pi to 0, and then I see again from union pi to 2 pi. I can't imagine they would give you a problem that easy. But if you did, lucky you. Okay, number 2, what are the values for which sine of theta is greater than root 2 over 2? Okay, so I'm still getting better at using the unit circle to help me with inequalities. But basically, my sine value is root 2 over 2, which happens here. So what angles give me a sine value that's bigger than that? Well, all of these in this area. And so we would say, can we equal root 2 over 2? We can. So I would do a hard bracket on pi over 4, and then a hard bracket on 3 pi over 4. Cool. Okay, there's more. Okay, so we're going to set these equal. Okay, so on this one, well, here's how I would probably think through this. I would probably look at this and say, oh, this is 2 cosine x plus 4, and I know how to graph that really well because I've already graphed things. And so I know that I have, the 2 stretches it, so my range would have been -2 to +2, but then the 4 sends me up. So I now go from 2, 1, 2, 3, 4, 5, 6 to 6. And since it's cosine, we start at the very top, then we're at the midline, and then we're here, and then we're here, and then we're here. Okay, and so we're looking, oh, okay, that's terrible. But we're looking something like that. And we want to know when is f less than 3? So 3 is somewhere in here. So we want to find, it's going to be, this was 2 pi, this was 0. So where it intersects, we want the place between the intersections. So now I'm just going to set them equal and then solve. And it looks like I'm relatively close to 0 and I'm relatively close to 2 pi. Does that give you a sense of scale a little bit? Okay, subtract 4, divide by 2, I get cosine of x is equal to -1/2. On the unit circle, cosine equals -1/2 here and here. And so we want to know, where is this one smaller than that? So it's going to be where it's more negative. It's also this place in between them. So I think our answer would be, this is 2 pi over 3 to 4 pi over 3. Let's double check. If we plug in pi, cosine of pi is -1. 4 plus 2 times -1 is, what did I say? 4 plus 2 times -1 is equal to 2. 2 is less than 3. So that is in the interval we want. Okay, next one. Oh. We want to know where is h greater than, okay, so let me set them equal. So we've got this 3 cosine x is equal to root 3 plus cosine x. Subtract cosine, that gives us 2. I don't have a ton of space, so now I'm going to divide by 2. So cosine x equals root 3 over 2, which hopefully you realize is unit circle friendly. When did this happen? So this is pi over 6 and 11 pi over 6 on the unit circle. Okay, so we need to know when is, well, okay, let's try a number line. We're going from 0 to 2 pi, and we have pi over 6, and we have 11 pi over 6. But notice these 0 and 2 pi are not intersection points. So I could use those to plug in and see which one is greater. Even normally we can't use things that we draw on the line, but these aren't zeros and these aren't asymptotes. These are just random domain restrictions that they've given us, okay? But actually, let's start with pi. That's easy. If I plug in pi, cosine of pi is -1. So this is h of pi equals -3. K of pi equals, root 3 minus 1. That's going to be, h is going to be smaller than k. Is that what we want? H is greater than, no, we don't want that. Okay, so we're going to want the outside intervals. Let's check and see, what is h of 0? H of 0, cosine of 0 is 1, so this is 3. And that's the same thing. It's also h of 2 pi. because plug in 2 pi, it's cosine of 2 pi is 1, so that's also 3. And then k of 0 would be equal to root 3 plus 1. Root 3 is not as big as 2. So something smaller than 2 plus 1 is going to be smaller than that 3 right there. So we wanted h to be bigger. Okay, that works here and here. And so we can use the interval. We can include 0 where it's greater. Okay, but we can't include pi over 6. So soft bracket here. We can't include 11 pi over 6 because it was equal, and they wanted it just greater than. And then we can include 2 pi because at 2 pi, it's great. That's a hard bracket. I ran out of space. I'm sorry. Okay, hopefully that helped. Oh, interesting. Now he talks about solving inequalities. We have 2 more. Okay. So here's how I would do these. I think I may probably need more paper. Let's just jump in here. Well, we'll have it ready. Okay, so I don't know what this graph looks like. Sometimes knowing the graph can really be helpful so that I can do my inequalities. But on this one, I can say 2 sine squared theta plus sine of theta. Where does it equal 0? Let's start with, what should we do? It starts with an F and it's an actor. Okay, we're going to factor out a sine of theta. I see sine of theta equals 0. I see sine of theta equals negative 1/2. Okay, so sine of theta equals 0 at 0, at pi, at 2 pi. Okay, notice that they've limited me to that world, so I don't really care about finding all of them. Sine of theta equals negative 1/2 at, that's on my unit circle, that's here and here, 7 pi over 6 and 11 pi over 6. Okay, so on this one, when I draw my number line, my sign diagram, can I equal 0? No, I can't equal 0. So I'm equaling 0 at 0 and at 2 pi and here at pi. And 7 pi over 6 is going to be here. And 11 pi over 6 is here. Sorry. Okay. Well, the annoying part is that there's not an easy number to work with in here that we know from the unit circle. Now, later, you'll learn how to find some of them exactly without a calculator, but it's just kind of annoying. And we can't use those zeros, so that's also annoying. Let's start with, did they call this anything? No. So let's do when theta equals pi over 2, I get 2 sine of pi over 2 quantity squared plus sine of pi over 2. Sine of pi over 2 is 1, so I have 2 times 1. This is equal to, so 1 squared is 1 times 2 is 2 plus 1 more is 3. Okay, so this is positive. What was I looking for? I wanted negative, so I don't want this interval. So odds are I want this interval. Let's see if it bounces. So let's try what's something between 3 pi over 2. Okay, so it's 2 times sine of that angle is 3 pi over 2 squared plus sine of 3 pi over 2. So sine of 3 pi over 2 is negative 1. Square it, we get positive 1. So 2 minus 1 is 1. This is the number 1. Okay, so this is also positive right here. So it better be those other intervals. I'm curious to see how they solved this. I can also, I can't really show you Desmos right now. Well, let's see. I love Desmos. It's fantastic. If I try and graph this, I'm going to see what I can do on my calculator. I'm in radians. We want to be in radians. 2, and I want quantity. I want sine of x, and I want it squared, plus sine of x. Where is sine? There it is, sine of x. I want to graph this. Let me set up my window. I'm just going to do that trig window. We'll see if I like it. Okay, so the good news, actually, let's change our window. Let's go from 0 to, we wanted 2 pi, so 0 to 2 pi, because that's the world that they've restricted us to. And it sure looks like to me that we dip down below here, and we dip down below here. I don't quite know the best way to tell you that we're not just going to bounce there and have everything positive. But the final answer is that we are less than 0 from pi to 7 pi over 6. We pick it up again from 11 pi over 6 to 2 pi. I can teach you how to do this middle part by hand once we know more identities, and we don't yet. So I'm curious to see how other teachers do that. Well, I just can assume, I mean, can we just assume? But anyway, okay. And then the last one that he has on this worksheet, what are the values where this is the case? I need another piece of paper. Okay, on this one, here, let me show you just a u substitution in case you want to see what I'm talking about. I can say let u, not me, equal cosine of theta, and this becomes 2u squared plus u minus 1. I'm going to just solve for zeros first. And so this can factor 2u and 1. U and 1, and I need them not to be the same sign. This one has to be positive, that has to be negative. U would either equal 1/2 or negative 1, but I'm not solving for that. I know cosine of theta would equal 1/2, or cosine of theta would equal negative 1. Cosine is the x, I equal 1/2. What am I writing? I knew I had two terms, so I was going to put a comma between them. I got there too fast. Cosine is equal to 1/2 at pi over 3, and then at 5 pi over 3. Cosine is equal to negative 1 at pi. Okay, so now on my number line, I have 0 and 2 pi. And the thing, those are not zeros and they're not asymptotes, so we could use them later if we needed to. And then I have pi in the middle, and then pi over 3, and then 5 pi over 3 is somewhere over here. This one might be better for us to plug in values. Okay, so let's see. Let's call this, and let's just give it a name. F of x, nope, theta. F of theta was equal to, it was 2 cosine squared theta plus, oh, no, just cosine. Cosine theta minus 1. Okay, so now let's plug in something between, an easy thing to work with between pi over 3 and pi is f of pi over 2. 2 cosine of pi over 2 is 0. That's great. Squaring 0 is still 0, plus 0 minus 1. This is equal to negative 1. What was our goal? We want to be greater than 0. This interval right here is less than 0. That's no good. We don't want that interval. Okay, between pi over here and 5 pi over 3, 3 pi over 2 will work out the same way. F of 3 pi over 2 is 0, and so this is also equal to negative 1. So this is also no good. Oh, okay. So we really do need to try something. So from 5 pi over 6 to 11 pi over 6, we need to try f of, which is easier to work with. It doesn't matter. 11 pi over 6. Okay, 2 cosine of 11 pi over 6. This quantity gets squared, plus cosine of 11 pi over 6 minus 1. Okay, cosine of 11 pi over 6 is root 3 over 2. When I square it, I get 3 over 4. This is root 3 over 2 minus 1. Oh, this is annoying. Okay, so I see 3 halves minus 1 is 1/2. So this is 1/2 plus root 3 over 2. I don't care what that value is, but it's positive. Did we want to be positive? Yes, we want to be positive. That's a good sign. Okay, and then let's do does pi over 6 work the same way? Yes, pi over 6 would also be that same case. So I'm thinking without my calculator that my answer is, can I include 0 and 2 pi? I can. I'm thinking we're going to go 0 to pi over 3. Can we include it? Yes. Can you see everything I'm doing? And then we're going to pick it up again from, what did we say, 11 pi. Oh, did I write pi over 3? I did. Okay, this should not be, I was trying 11 pi over 6. I want to go from 5 pi over 3 to 2 pi. Notice I was about to write down different angles in different families, and I was like, no, that can't be right. So I caught my mistake doing that. Okay, let's check our lovely little calculator. You wouldn't have a calculator on this problem, but let's just make sure I didn't lie to you. Okay, so delete this mess. I see 2 cosine of x. I'm squaring that. I'm adding cosine of x, and then I'm subtracting 1. Okay, and then let me make sure that I don't, yeah, that should be in parentheses. I mean, it should be fine without the parentheses. Let's draw Okay, so what were we looking for? We wanted it to be positive, and we said, let's do G solve. This is where Desmos is great because I can do my roots on Desmos and it'll tell me what's up. So if I take this number on my Casio, I can come back here, I don't know what I was, and hit X equals, and then I'm thinking that this value was pi over 3. Okay, yeah. And they match. So that's a good sign. On Desmos, it would have just told you pi over 3, which is great. The other one should be 5. Where's pi? Pi over 3. Tell me the approximation. Fraction to decimal. There we go. So I should see a 5.235, whatever. Let's go see. Menu, graph, draw, G solve, root. Not that one. This should be pi. 3.1415. Okay. And this should be that. What did we just say? 5 point whatever mess? Oh, come on. There you go. I think that looks familiar. Okay, so that's a good sign. So this one bounced. How can I guarantee that the other one didn't bounce? I don't know. Let me keep thinking about that. There are identities that help you find a value in between those. So worst case scenario, save it for the last part of your AP exam or something, and then use the sum and difference identities to find something. Do you remember the problem I'm talking about? Now I can't find it. Where we didn't have something nice to work with here. We could use 13 pi over 12, and when you've learned sum and difference identities, you can find the value of sine and cosine and stuff of 13 pi over 12 without your calculator. It's just annoying. So I don't want to teach it now. Anyway, there is a way to do it. You will learn it at some point, but you don't know it yet. All right, so like, subscribe, comment, let me know how I can help you, and of course, go practice.